So what exactly is a linear equation? Well, the dictionary defines this as an equation between two variables that creates a straight line when plotted on a graph.
Whoa. Linear equations should not be that hard to understand. A linear equation is just an equation that makes a straight line when put on a graph.
Anyway, there's three basic types of linear equations. There's standard form, point-slope form, and slope-intercept form.
Let's start with the basics. The most common linear equation is slope-intercept form.
So slope-intercept form by itself is represented by y equals mx plus b.
There are multiple ways to graph a line using slope-intercept form. My way is that you take the rise over the run, and in this situation that would be 3 over 1. And for every 3 units you go up, you'd go 1 unit to the right. Now that we have our basic line, we can input the b value. This means that we can translate the line up or down depending on the value of b. In this case, our value of b is -1, so we translate this line down 1 unit.
There's also a second way to create your line using slope-intercept form. This is easier for some people, but harder for others. So the whole goal of using this method using point-slope form to create your line is to find 2 points on your graph, then connect those together to make your line. So in this process, we're going to take 2 separate points on the x-axis. For my example, I'm going to use 2 and 4. So what we're going to do is we're going to take these 2 different points and input them into our equation, y equals 3x minus 1. So our first x value that we're going to use is 2. We're going to input this value into the equation, and this gives us y equals 3 times 2 minus 1. After you do all the math, this leaves us with y equals 5. Then we're going to combine the x value and the y values that we have, and that gives us one of our points, 2, 5. Now we're going to do this again, but with a different x value, 4. We're going to input 4 into our equation, which leaves us with y equals 3 times 4 minus 1. After you do all the math again, this leaves us with y equals 11. Then we combine the x and y values together to give us another one of our points, 4, 11. Now all we have to do is connect these 2 points together. And believe it or not, if you did your math correctly, this line that you just created will be the same line that you created using method 1.
Another form of linear equations is point-slope form. Point-slope can seem really confusing at first, but it's actually pretty simple. Say we want to find slope-intercept form from a line we already created. This is where point-slope comes in.
When we use point-slope form, all we're doing is taking 1 point from our line and inputting it into this equation. Y minus y1 equals m times x minus x1. So you're probably thinking, you know what y and m and x are, but you probably don't have any idea what y1 and x1 are. So what we do with this y1 and x1 is very simple. All we do is take 1 point on our line and input the x and y values into those places. So if the point was 3, 5, we would put 3 where x1 is and 5 where y1 is.
Next, we're going to try to find the slope. Say that the slope is 2. 2 represents m, so in the equation we put 2 in the slot of m.
So now for the solving part of point-slope form. We have our equation, y minus 5 equals 2 times x minus 3. We're going to simplify this down to the most we can, and this leaves us with y minus 5 equals 2x minus 6. Remember, we're trying to get this equation to slope-intercept form. So to do that, we're going to move the 5 over to the other side of the equation. This leaves us with y equals 2x minus 1.
Now we've simplified all of our data from point-slope all the way to slope-intercept form. Now for the final form of linear equations, standard form. Now standard form by itself is ax plus by equals c.
So how do we get standard form? We get our standard form from slope-intercept form. So let's say our slope-intercept form is y equals 3x plus 2. So what we're going to do is, since standard form is ax plus by equals c, we need the x to be in front of the y. To do this, we're going to move 3x over in front of y, which makes our equation negative 3x plus y equals 2. Normally we would stop here and say that we had our standard form of our equation, but one very, very important thing to remember with standard form is that a, or the number in front of x, must always be positive. So since this is negative 3x, we're going to multiply the entire equation by negative 1. So instead of this being negative 3x plus y equals 2, this turns our equation into 3x minus y equals negative 2. So now we know all three different types of linear equations: standard form, point-slope form, and slope-intercept form.
Next, we're going to be showing you different strategies for solving systems of equations.
So there's probably two questions going through your mind right now. One, what are systems of equations? And two, why do we need to solve these? Well, systems of equations are pretty basic by themselves. They're basically an equation with an x value, a y value, and what those values equal to. An example of this would be 3x minus 5y equals 6.
So this is going to be our first method of systems of equations, and this one is called the substitution method. So what we're going to do is we're going to take the x here and we're going to plug it in to this equation. So it would be 3 times 4y minus 3, because it already tells us what x equals up here. So then we plug in the rest of this equation, plus 4y equals 23. So from here we just solve. So 3 times 4 is 12y minus 9 plus 4y equals 23. Now we add 9 to both sides to get 12y plus 4y equals 32. And then we just add these two to this. So now we have 16y equals 32. So if we divide each side by 2, or 16, my bad, 16, then we get y equals 2. Now we figured out our y value. Now we need to plug the y value into this equation over here so we can find out the point for x. So since y is now 2, it would be x equals 4 times 2 minus 3. So x equals 8 minus 3, which is 5. So x equals 5. So now we have both of our points. And so at the point 2, at the points 2, 5, right here, this is the points at which these two lines intersect.
Equations is the elimination method. Now, what we're doing with the elimination method is we're trying to get either the two y values in the equations or the two x values to become equal. That way we can go on with the processes that we need to get our point, which I'll explain later on in this part. So let's say that we're trying to get these two y values equal. So that's pretty easy. We can see that a very common multiple of 5 and 2 is 10. So if we multiply this top equation by 2, then we get 10. And if we multiply this by 5, we also get 10 for the y values. So let's go ahead and do that. We're going to multiply this equation by 2. That will give us 30 let me draw a line, 30x plus 10y equals 20, because the entire equation is multiplied by 2. So remember, you have to multiply what's on the outside by 2 also. Then we're multiplying this by 5, so that gives us 5x minus 10y equals 50. So that's correct. Now, since this is the elimination method, you can now eliminate this y value from the equation. So now that we have this out, we're going to go ahead and write what we have left, which is 30x equals 20 and 5x equals 50. So now we're going to combine these two equations together, and what I mean by that is we're going to add the x values together and add the integers on the other side of the equation together. This gives us a very simple 35x equals 70. Now we're going to do this math, which gives us x equals 2. So now we've done the first half of our elimination method. We found that our x point of our equation is going to be 2. Or not the x point, the x side of our point will be 2. But now we need to find the y side. So how are we going to do that? Well, we're going to input this x value 2 into one of these equations. So I'm going to go ahead and erase all this stuff that I have down here just to make this math easier. It's always good to have a good eraser on you. Just a handy math tip. Anyway, now we have the x value of 2. I'm going to go ahead and write that just to help us out. X equals 2. So this equation down here I think will be a lot easier to do than this, just because the numbers are smaller. And so we're going to input 2 for x. So 2 minus 2y equals 10. So in other words, we're figuring out 2 minus what equals 10. Well, 2 minus, this is pretty simple, 2 minus negative 8 equals 10. So since negative 8, I'm going to go over here now, negative 8 equals negative 2y. So I'm going to put that over here. We're going to divide these both by 2, which will give us negative y equals negative 4. Then we'll subtract, or not subtract, we'll multiply this by negative 1 to make this equation positive, because we need a positive y, and that gives us y equals 4. So we're going to put 4 over here for our y value in the point, and that gives us our grand point of 2.4. So the third way of solving a system of equations is pretty simple. This is the graphing method, and it's pretty self-explanatory. All you do is you take your two equations and graph them on a grid. To do this, you have to simplify the two equations like I did over here. From negative 4x plus 2y equals 4, I got y equals 2x plus 2. And after simplifying 2x plus 2y equals 10, I got y equals negative x plus 5. I would recommend doing this on a graphing calculator, but since I do not have one with me, I decided to make my own grid with a ruler. After graphing these, I got these two separate lines. These lines together meet at the point 1 and 1, 2, 3, 4. They meet at the coordinate point of 1, 4. let me rewrite that so that looks better, of 1, 4. So, all we had to do was take our equations, simplify them to y equals x plus whatever, and then graph them on our grid. Now, I would not recommend doing this if you don't have a graphing calculator, because you can actually get your equations wrong. If you have something that goes into a line that goes into decimals or fractions, you're more than likely not going to get the correct intersecting point. Luckily, my two equations that I created they intersect at an exact point. So that's the graphing method for solving systems of equations. So throughout this video, we've showed you the different types of linear equations and the different methods to solve systems of equations. The three different types of linear equations are point-slope form, slope-intercept form, and standard form. The three different ways to solve systems of equations are the elimination method, the substitution method, and the graphing method.
Well, I hope you enjoyed our video. I hope this helped you with geometry, and make sure to like and subscribe and check us in the next video.